不是你说那个别人进去，你要让我进我要是觉这都消失了。这啥呀
You guys do question one, please. Can you guys do question one, please, now? And you have about question one. By the way, has everybody got the lecture notes from the lecture? Has anybody here that's got a copy of this? The lecture notes? Yes. You guys got a copy of this? Yeah? You guys? Some of you guys said you will get it. I don't know. You have a copy of this one? And you guys do question one, please, now. Then you make sure that you sign your name in the attendance sheet. There's an attendance sheet going around here. Make sure you sign your name, okay?
That's right.
All right, let me show you how to do this. All right, I mean, all of you guys, the normal distribution, you should have seen this in your probability 2 course, right? So the MGF is, right, because this is a continuous variable, you're going to do an integration, as I said this afternoon, E of tx times the PDF of the normal, which is I mean, you've probably seen this 100 times already, I don't know. I mean, the PDF of the normal is is this one, right? I mean, you must have seen this many times already, or no? Yeah, this is the density of the normal distribution, right? So I'm gonna write it like this. This is a constant, so you can pull it out. Yeah.
So you see what I'm doing, right? I've pulled out this constant outside the integral sign, right? So that means you are left with this. Yes? The next step, I'm gonna take this as a common factor. So it becomes 2 sigma squared t Yes? Are you with me so far? Right, now I'm gonna take a minus sign out. And you guys listen please. If you haven't done this. If you have done it, you can ignore me. But if you haven't done it, can you please listen to me? Okay? I'm taking a negative sign outside, right? And open the brackets here. So that will give you yes? Yes? So I open the brackets here, so that gives you 3 terms. And I'm taking the negative sign outside, right? All right, in the next step, I'm going to take, you see there are 2 terms that contain x. This term and this term, both contain x. And I'm going to combine the 2. So that gives you this, right? So I'll combine this term and this term into this. You follow me, guys? Yeah? Right. The next step is the crucial step. I'm going to do something known as, I think you probably know this. All right. Do you see what I have done, guys? What what have I done from this step to this step? It's known as what? Huh? This step here is known as completion of squares, right? I have written this in this form, right? It's known as the completion of squares. I'm sure you've seen this before. Not the it's not the first time you have seen this, I'm sure. Right, so now I'm going to write this in the following manner. Dx right. Now I'm going to ask you a question about this guy. What can you say about the thing I have put in a box? What can you say about it, guys? This guy here, what is this equal to? Huh? Yes. this is equal to 1. And you see why? Because the right, and you see that or no, guys? The thing inside the box is equal to 1 because what you are integrating from minus to plus infinity is the PDF of a normal distribution with these parameters, right? And any PDF, I'm sure you know from probability 1, any PDF must integrate to 1. That's the basic fundamental property of a probability distribution, right? Any PDF must integrate to 1, right? Okay? You follow me, guys? Or no? All right. Therefore, the answer is equal to this, and this guy here can be simplified to this after some labor, which I'm not gonna do. I expect you to do that. After some manipulations, you can simplify this to this, which is the answer. All right. So that completes question 1. Any questions, guys? Are you all right, guys? Or no? You are set? Yeah? All right. Do you follow that or not? I'll put this on your part. By the way, guys, this thing here is outside the integral sign. This term here, right, is outside the integral sign because there's no x in it. This term is a constant. There's no x in this term. It's outside the integral sign, right? And this, after some labor, reduces to this. It shouldn't be too difficult. I need to show that this is equal to this, right? Okay. Any other questions, guys, on this, on what I have written down before we go to question 2? Are you all right, sir? Can you, okay, if you're okay, can you do question 2 now? Can you guys do question 2 now, please, if you're okay with that? You okay, man? You follow that? Can you guys do question 2, please, now? Not for the exam. For the exams, the formulas are on the course page. If you go to the course web page, there are list of formulas you need to remember. All right, guys, can you listen to? Shh. Can you guys listen, please? Hello? Shh. Can you guys listen? Let me show you how to do question 2, right? Now, you're given two variables, x1 and x2, which are independent normal variables. And we want to show that this guy here is also a normal variable. Okay? Now, to do questions like this, the standard approach is the following. Let me start with the left-hand side. Let me call this y. And you can call it anything you want. It doesn't need to be y, right? All right. Then the MGF of y, I'm trying to find the MGF of y, which is this, which is the expectation of this, yes, and this is the expectation of t yes. Now this can be written as right. Now using independence, right? Because x1 and x2 are independent variables, you can write this yeah, you can write it like this. Yeah. Now this guy here is the MGF of x1 at TA, and this is the MGF of x2 at TB, and this is a constant expectation of e to the power TC. Now we know from question 1 the MGF of a normal variable is given by this formula, right? So therefore this guy is simply E of mu1 TA plus this, okay? And once again, using this one can be written right. Are you guys with me or not? Now what you have here is a product of 3 exponential terms. Now remember, when you take a product of exponential terms, you are adding the powers. Okay? So this can be written as follows. Okay. Now, so this is equal to this. Now, you should compare what I have written here with what we have here. What do you see? I mean, what's the similarity between this expression and this expression? And you see the similarity between these two? Yes or no? You see that in place of mu, we have mu1a plus mu2b plus c. And in place of sigma squared, we have this expression. Therefore, what you have here is the MGF of a normal variable with mu equal to this, and sigma squared equal to this. All right? You guys with me or not? Because of the similarity between this and the thing I have circled in a box, right? Yeah. Because of that, what you have here is the MGF of a normal variable, right? And therefore, the conclusion is that y must be a normal variable with these parameters. All right. So that completes question 2. Is that does it make sense or not? Remember, y is what I call ax1 plus bx2 plus c. Is that clear to you or what? Any questions? You guys okay? Yeah? All right. You okay? You okay with that? Yeah. All right, good. And can you now Are you guys okay? Are you able to follow that or not? Good, good. What about, are you guys okay? Yeah, good. You're right, sir. You have a question? Mr. David Madden? Yeah, it's pretty much the same as what I put down. Yeah, yeah. It's the same as what I put down over here. It's good, yeah. It's good. What you done is correct. Can you now do question 3, guys, please? Can you do question 3? And you guys make sure that you sign the attendance sheet. So everybody sign the one. Where's the attendance sheet, by the way? Did I give it out? Well, I gave it out. You right? Oh, nice. Has somebody got that attendance sheet with them? No? Yes. You guys sign that? Sign that? You guys got that finished? No. You guys sign this? No. Sorry, guys. Sorry. What about you guys? You sign it. And you guys do question 3, please, now. So if you guys sign, hello? Yeah? All right, let's see. Shh. All right, you guys listen for a second. You haven't done this. You can ignore me if you have already done this. You can ignore me, right? All right. Now, to do this question, I'm going to use the same approach as question 2. So I'm going to start with the left-hand side, which is x bar, right? And find the MGF of x bar, right? Which is this, which is this, right? And this you can write as like this, okay? Because x bar is it's the sample mean of the data, okay? So this you can write as okay, right? Now this, because of independence, using independence you can x1 to xn are independent variables, right? Using that fact you can write this you can write it like this. We also know that x1 to xn are identical variables, right? In addition to that, we know that this guy here is simply the MGF of x1 at t divided by n, and this guy here is the MGF of x sub n at t by n. And since x1 to xn are IID random variables, we can write this as power n. All right. Now we know from over here, this is the formula for the MGF of a normal variable, right? So I'm going to use that in a sec. Okay, this is going to become, using this formula, raised to n. All right. You see what I've done here. I have used this formula. To compute the MGF at t by n. Okay, which is this. Now, taking the power n, you get this. Now, what can you say about this, guys? This guy here, what is this? Now, you should compare this once again with this one. Do you see the similarity between this formula and this formula? The difference is that mu t you have sigma squared t squared, but here you have sigma squared by n t squared. So what you have here is the MGF of a normal variable with parameters mu and sigma squared by n. Yes? No? Do you see this or no? Yeah? And therefore we have shown that x bar is a normal variable with parameters. Okay? Alright, so that completes question 3. Alright guys. Can you do question 4 now, please? Question 4. I only use it for some Are you guys okay? What's good? Shh. All right, let's look at question 4, guys. So you're told that x is a uniform variable. The notation you and I, you shall see in the lecture notes, if you have looked at the lecture notes, u and I refers to the continuous uniform distribution, right? Which is, I'm sure you've seen this before in probability 2. The PDF or the probability density function of a continuous uniform variable is defined by this, right? And here we want to find the MGF of x. Okay, so it's gonna be the integral from a to b of e tx times the PDF, which is this. Okay, so this will be the integral of this, guys. You should know what's the integral of this, guys. This is the integral, right? Now taking the limits, you get the required answer, which is e of tb minus e of ta divided by t. All right? I'm sure this is obviously an obvious question, right? I'll probably not give you this in the exam, right? Yeah. So. There, all right. Now, next one. The next one is question 5, where the notation exp, refers to the exponential distribution. I'm sure you have seen this before in your previous courses. Yeah, and this is the PDF. This is the PDF of an exponential distribution or random variable. So the MGF is the integral from 0 to infinity of yes. All right. Now, doing this integration, you get lambda. You can pull it outside. Inside the integral, you have e of minus yes. Taking the integral of this, you get sorry. What am I doing? Sorry, guys. All right. The limit at infinity is 0. right? The limit at 1 is this, right? And therefore the answer is lambda by lambda minus t. Okay, so this is the MGF of an exponential random variable. Is that clear, guys, or not? Can you do question 6 by yourself, guys? I think we run out of time. So, can you try to do And you all got copies of the lecture notes. Anybody who hasn't got a copy of the lecture notes? You Anybody else, guys? Anybody else? You have a copy of the notes? You have this? You have questions?